Okay, so today we're going to look at correlation. But before we talk more about correlation, we need to talk about correlation and causation. So we already know the word correlation means a linear association. So when we see the word correlation, we should be thinking linear association. Or another word that we should be thinking is relationship. So, what we know is we can have a relationship between two variables without one variable necessarily causing the other. So, there is a correlation or relationship between the number of firemen fighting a fire and the size of the fire, because the bigger the fire is, the more firefighters will be there. However, just because more firemen come to the fire, it will not cause the size of the fire to increase. So there's more firemen likely because there's a bigger fire. However, lots of firemen can come to a small fire. So let's look at these ones. A recent study showed that college students were more likely to vote than their peers who were not in school. That's just a correlation. Things happen when you're in college, when you get an education, that tend to lead you to vote more. However, just because you earn a degree does not force you to vote. So it's just correlation, it's not causing you to vote. Same thing with the next one. Yeah, because as the day goes, there will be more trash in the hallway. So there's going to be probably more trash in the hallway second period than first. But just because it's second period doesn't cause there to be more trash. Because let's say one day, for whatever reason, they had to put period one at the end of the day, and period two was the start of the day. Just because it's period two isn't going to cause there to be trash in the hallway. It just happens to have more trash because the day has gone on. This last one, however, is causation. Your sister is crying because of what you did. So we've already seen the correlation coefficient a bit. We've seen it show up a few times on our calculators when we ran the linear regression. We use the letter R to represent the correlation coefficient. R is always going to be a number between -1 and +1. And it tells us two things. If it's positive, that indicates that there's positive correlation. If it's negative, that indicates that it's negative correlation. And it also tells us how strong it is. The closer R is to 0, the weaker it is, the weaker the relationship is. The closer R is to either 1 or -1, the stronger the correlation is. So here we have a chart with some examples of the type of correlation you can have. If you have a -1 value, that is a perfect negative correlation. So it's a perfect straight line going in the negative direction. Versus anything between -1 and -8 would be considered strongly negative. So if you had a value of negative 0.96, that's a pretty strong and negative correlation. Once you get between about zero point 0.8 and zero point 0.5, we're going to call it moderate. And anything between zero point 0.5 and zero point 0.2 we'll call weak. Anything much below zero point 0.2 is going to be considered no association. That is almost hardly any relationship between the data. And then again, you see the strength mirrored, right, into moderate, strong, perfect, except now instead of negative, because we had negative correlation coefficients here, they are now positive. So again, it's telling us two things: how strong the relationship is and whether it's positive or negative. So if we were putting these in order from weakest to strongest, first we want the number with the smallest absolute value. So that's 0.07. The next smallest absolute value is 0.43. The next weakest would be negative 0.81, then 0.87, then negative 0.98. Here, the weakest one is 0.04. If you had a 0.04, that means no association at all. 0.32 would be weak positive association or correlation. Negative 0.04 is the next weakest. We would still probably consider this weak, but negative. Then we would have 0.63, which would be a moderate positive, and negative 0.65 is actually the strongest number in this list, but it would still be considered pretty moderate. So to me, this graph is relatively moderate in the positive direction. So that would be a 0.5 R value. So we would say R equals 0.5. This one, on the other hand, is close to being strong. So is it a perfect one? No. Oh, negative one rather, because it's negative. Is it a perfect negative one? Maybe not. Maybe a better estimate would be negative 0.97 because it's strong, but it's not perfect. So it's going to be closest to negative one, but I don't think it would be exactly negative one. Same thing with this one. This one's very strong. However, I wouldn't call it perfect, but maybe it's about 0.96. But it is positive and it's going to be closest to 1. This one looks very random, so we would say 0, no association at all. And I think this is the same one. We would still say 0. This one would be negative because it's trending downwards, but it's on the pretty weak to moderate side, so negative 0.5 would be a good estimation. So if we were to chart the number of hours we work and the amount of money in our bank account, we would probably consider that positive correlation because as the number of hours increase, your bank account increases. Next, the number of hours workers receive safety training and the number of accidents. Well, the more hours you receive of training, the less number of accidents. So that would be probably negative. And the number of students at KP versus the number of dogs in West Hartford, I would say that probably has no correlation. If anything, we could maybe say it has a weak positive correlation because if there's more dogs, that means probably more people live in the town. So there may be more students, but they're going to be only weakly correlated to one another. The number of heaters sold versus the months in order from February to July. So the number of heaters will start high because we're starting in February and then go down as we get closer to July. So that's going to be a negative association because you're going to have more in February sold and much fewer left in July. This one definitely has no correlation. And the last one is going to have positive correlation. So here, we'll zoom in a little bit so we can see this better. We are looking at some data that was entered into a graphing calculator and the linear regression that was outputted by the calculator. So we know A and B give us the equation of the linear function. So that's going to be a linear equation 1.5x plus 16.32. And at the bottom, they give us the correlation coefficient. So R will always be listed at the bottom of a graphing calculator screen. I'll show you how we can get that using the graphing calculator. But in this case, the correlation coefficient is 0.976. So that would tell us that this is strong, positive correlation. We will talk more about the R squared value later on in this unit when we discuss the difference between a linear regression, a quadratic regression, and an exponential regression. But for now, just know that R is our correlation coefficient, which tells us the strength and the direction of the correlation of a data set.